I appreciate the discussion. That's what I want to see. Another minute, just give it a shot, get somewhere, and if you get stuck, you get stuck. Not a big deal. You could, but don't dwell on it. It's a good point. It's a fair point. Even in life, it's not saying you're not allowed to have bad emotions, right? That's not what they're saying. You can be upset and frustrated, but don't dwell on it. Shall we? You want to try it? I'll give you another minute. Because remember, the goal is to work it out. It's not necessarily just the right answer. Zero, 1, 2, 3, 4, 5, 6, 7, 8, and 9. I will use blue. I will use a thicker pen, and here we go. All right. I'm going to get started. I'm going to get started by first letting you know a couple of things that might help. Did you know that if you multiply an even with an even, you get an even? Like 2 times 4 is always going to be even. Did you also know that if you take an even with an odd, it's always going to be even? Surprise. 2 times a 3. Why is that? Well, let's use this example. 2 times 3. That means I take a 3 and I'm adding it twice. Or maybe I could say 3 times 2. I take a 3 and I'm multiplying it by 2 because I'm doing 3 plus 3. If you didn't know, multiplication is just a symbol of adding again and again and again and again and again. Right? So if I say something like 3 times 5, that means 3 plus 3 plus 3 plus 3 plus 3. Who's got time to write that 3 5 times? Not mathematicians. You will learn in time that every single day I will say mathematicians are the laziest people on earth. If there's a short way to write it, they'll do it. If they need to create a new system to write it shorter, they will. That's how lazy we are. Right? So when someone tells you show all your steps, mathematicians will be like, oh my God. But it's necessary in the beginning. And then as you write the steps more and more, you'll be like, okay, I understand it. Stop, Mr. Kim, I get it. And then you'll start to skip steps. That's where we want to be. So here, a 0 would be even, technically speaking. Yes. All right. So let's do this. Last thing, an odd times an odd. Odd. Like 3 plus 3 plus a 3. In other words, 3 times 3. It's always going to be an odd. So I'm going to use that to my advantage. If I want this to become an odd, a division, in other words, it's the reverse of a multiplication. If I want it to be odd, I need this number and I need that number to be odd. I need an odd divided by an odd. 3 divided by 1. 3 divided by 1 is a 3. So I'm going to start there. I'm going to start it. Remember, there was no real math per se. It was just, I'm going to try it. Because I have no idea. This is like, well, it's not the first time I saw this puzzle, but it's been a long time. Okay, moving on. So I have 1, 2, and 3 used up. Next. Ooh, I have a multiplication. And then I have an addition. If this was an odd number, and this was an odd number, would I get an odd number?
No.
No. So I need either this to be even, or I need that to be even. You see the puzzle in all this? So it's up to you. There's more than one answer. So I'm going to try. I'm going to make this an odd. Maybe I'll do 5. And I'm going to make this an even. Maybe I'll do 4 times 6. So 4 times 6 by bed mass is 24. And I'm adding it with the 5. My answer is 29.
The answer doesn't have to be within 0 and 9.
No, as long as it's a different odd number. Oh, that's what you were doing.
That's why you're getting stuck.
Ah. And the third one, that means I used up 4, 5, and 6. I have 0, 7, 8, and 9. So, last one. I think, again, with some trial and error, I think I could probably do it. But here are some clues. I am subtracting by something and I'm dividing and multiplying. So the division and the multiplication have to come first. When I am multiplying or dividing between these numbers, like whatever this turns into, and that first square, it's got to be a difference of an odd with an even, or an even with an odd, one or the other. It's got to be. But I'm going to cheat. Watch this. What is 0 divided by 8? 0. And so that is a 0. 0 multiplied by 7 is 0. So I cheated. I made that entire thing turn into a 0. And so I used up an 8. I used up a 7. I used up a 0. All I have is 9 minus 0 is 9. So it's a puzzle, but it does require to know 2 things. One is just a sense of numbers and be like, what could I do with it? Like even times even times odd stuff. And number 2, your understanding of bed mass. It's going to be important. And that's where we're going on today. Okay. I'm hoping that it won't take too much of your time. We are going to go through the order of operations for integers, adding and subtracting, multiplying, dividing, of course, and then bed mass is exponents, and then we throw in brackets. We need that as a foundation, as a building block. I will also have homework questions for you to do. Come Monday, the answers are already here. I am going to do a homework check essentially every day. I'm going to be that teacher. I am sorry. But let's be real. Better safe than sorry when we're coming back from COVID, right? I'll explain when we get there. But when you look at the sheet, every single sheet that I give you is always going to have a section that says your turn. Get it? Because it's your turn. Funny, right? Okay, I'll just stop. Anyways, let's move on. Moving to our little camera. You do not need to see my face. Oh boy. Yeah, of course. But again, I do not know what background anyone is coming in with, depending on school, depending on skill, depending on how hard you worked last year. Okay.
That's like the magnifier thing.
Like the camera?
Yeah, we use that last year.
Oh, okay. Oh, okay, I misheard you. Yes, Ryan.
What's your policy on using your phone as a calculator, like the calculator app?
Oh, that's a good point. Let's put it this way. All right, let it be known, YouTube, okay? Calculators, you must have a separate regular calculator at some point this year. Let me tell you why. Phones clearly are not allowed during evaluations because this is not only a calculator, this is essentially a supercomputer, right? And so you need your own calculator for the sake of, in academic integrity and blah, 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 all that stuff in the PDSB. But more importantly, we as human beings are creatures of habit. We will get used to punching your machine in a certain way. If you borrow a calculator from someone, borrow from me, borrow from a friend, you will not be used to that particular calculator. It will slow you down, wasting valuable time. And I'll say this right now. If you do not have a calculator on you and you are planning to buy one, please buy a calculator that has an answer button separately. Yes, please. A business calculator will start tripping you up when we get to grade 10, when you start using this funny symbol called sin, cos, and tan. Actually, it's sine, cosine, and tangent. A couple of other things, but I won't get into it. I think it's going to improve your quality of life if you have a button specifically dedicated to answer. Why? This is what you do. For example, let's pretend, give me two numbers, Cindy.
6.
Thanks, Cindy. 6 and 4. 6 times 4, 24, right? And then the next question was, at 24 is subtracted by 10 or whatever, right? Instead of writing 24 minus 10, you literally press answer, the previous answer, minus 10, and you get 14. The answer is saved every single time you press the equal sign. And so let's say, for example, you're doing, oh, for real? Elliot? Yeah, come on in. Come on in. For example, let's say you're doing Pythagorean theorem. Everyone here remember Pythagorean theorem? You may not remember how to do it, but do you recognize the name Pythagorean theorem? Okay, let's say, for example, you're calculating Pythagorean theorem, and then you have like, the hypotenuse is a 12, right? So 12 squared, and you're trying to find the side, you do like minus 8 or minus 10 squared, and you get this, right? How do you find the actual sign? You have to square root it. And instead of writing square root of 44, you can do, so 12 squared minus 10 squared, right? Square root of the answer, and you get the same number. And not only that, let's say that number afterwards, you have to like multiply it by a 2. Instead of typing 6.6332495 times 2, you can just do answer times 2. That answer button is going to improve your quality of life. So if you're getting a calculator, get one with an answer key. Have I preached enough? You guys get what I'm saying? Please get that. Okay. So that's my policy. You can use it during class, but you won't be able to use it during tests. But if you can't use it during tests and you want to practice saving time, might as well not use it during class. Of course. I'm never going to stop you. Just don't get distracted by the 10 million people that want to talk to you, because you're clearly way too popular for me, right? Try not to be distracted by your texts, your Instagram posts, your Snapchats, your TikToks, your everything. Okay? Try not to be distracted, please. You are allowed to chill and relax and use your phone after the lesson. If I do give you some time in class to try to work on the homework questions ahead of time. But if I'm giving you time to do homework anyways, why not just do it now and then save the time to play at home? That's just me. You could find it a little different. Yes, Amy?
What is the thing and minus number thing? Like the second
This stuff?
Yeah.
Sure. Okay, so let's get to it. Yes, yeah, go quickly and make sure you put your name on. All right, integers. Does everyone know what an integer is? If you do, put your hand, nod your head. Okay, so half the people don't know what an integer is. Does anyone else know any other family of numbers? Anyone here of the family whole numbers? Yeah. How about natural numbers? Yeah. How about rational numbers? What's the difference? Yes. What about it? Okay. Oh man. Quick, super quick, super quick. Crash course. When you are first born as a baby, what are the first numbers that you learn? 1, 2, 3, all the way to? Well, as far as they can count, of course, right? So I'm actually going to write infinity. This group of or family of numbers is called the natural numbers. You learn them naturally. But as you start learning the concept of natural numbers and you start looking at, things that you like as a baby, like cookies and candies and whatever, and you decide to eat them all, what happens when you eat them all? How many cookies do you have? None. In other words, you learn the concept of 0, and those are whole numbers. The only difference between natural and whole numbers is 0. And then as you grow up, you learn the concept of money. And not only could you have money, you could also owe money. Debt, negative numbers. So you have negative infinite, or as high as you can count, right? All the way to -2, -1, 0, 1, 2, all the way to positive infinity. And that is what we call integers. And then after that, you start learning about pieces, like fractions, AKA ratios, AKA rational numbers. Any number you could write as a fraction is a rational number. Things like 4/3, 1/295, whatever, right? Anything that can be written as a fraction. So not every decimal, but most decimals. With me so far? And then the big family on top of that, outside of that, is what we call real numbers. Basically, any decimal out there. I don't care if it's pi, I don't care if it's Euler's constant, I don't care about whatever. Any number, any decimal. There is one set I just mentioned that doesn't fit as a fraction, but is still part of real numbers. So there's a little bubble here called irrational. And that is not Q with a little bar on top. I just mentioned it. What is one number you can't write as a fraction? A number that goes on forever. 1, 2, 3. Who said that? Was it Nate? Yes. You said pi. Pi cannot be written as a fraction. 3.141 something. There was actually a recent article, I don't know why people did it, but they were able to find the trillionth decimal or something of pi recently using a supercomputer. The record was like the 100 billion or something. Yeah. But there it is. So we right now are going to not get into real numbers. You will see that the most popular group of numbers is integers and real numbers, either negative plus positive whole numbers or any decimal. And that is what we are looking at now. These are integers. Therefore, negative infinity all the way to positive infinity, no decimal. When you are adding or subtracting, don't get too twisted. When you're adding a subtraction, or when you're adding a negative, it's the same as subtracting a positive. Where's my pen? Let me write this down. If I am let's say, for example, 2 plus a -1 is the same as saying 2 minus a +1 or 2 minus 1. It's the same thing. There are two ways. Yes, and vice versa. You know, like an equal sign, left equals right side. I could explain that in two different ways. One is just, it makes sense if you think about it like temperature. Let's say, for example, outside it's 2 degrees. And I add a negative temperature to it. In other words, I'm adding cold to it. Does the temperature go up or down? If I'm adding cold to it, it goes down. So I'm adding a negative, it becomes 1 degree Celsius. In the same way, 2 degrees Celsius, if I'm subtracting a positive number, I'm taking away a positive number, well, it's the same idea. Okay? So Damien was asking, what the heck is the bracket thing? Well, that's where algebra can come in. Did you know, I think you do know, that if you have a number in front of a bracket, it represents a multiplication. So in this case, it's like 2 times a 3 equals 6. A plus -8 is like saying a +1 is in front of a -8. So positive times a negative is negative. 1 times an 8 is 8. This is the same as saying 4 minus an 8, which agrees with the rules that we just stated. What makes sense to you? Use that. If you just want to say, okay, I'm just going to memorize these rules and go with it, do it. If the idea that the plus actually is a +1 and you just got to multiply, do that too. Whatever makes sense to you. Okay? I'd like to give you, I'm going to say, maybe about like 30 seconds or so, maybe a minute. Could you attempt these, please? See what that means, okay? And if the analogy of temperature works for you, a -9 degrees, you take away cold. What does that mean? I'm gonna give you a minute. Give it a shot. Resume. Okay, so for me, again, you need to understand how much practice I've done. One day I'll tell you my story and my journey with math from kindergarten all the way till now. It's actually really weird. I would never have dreamed I was going to teach math, but here I am and I love it. But 7 minus 13, to me, I actually visualize it as a number line and I'm traveling, but I've done that so often that now it's a waste of time if I imagine a number line. That's how I got around it. But the key is I've done it so often that it became very natural to me. I hope you'll find a method for you too. First one, -6. Next, -4. Third one, -5. And the fourth, -3 plus 5 plus 7 is a +9. Yes, Zoe.
Should we put the positive sign when we're
You do not have to. This is okay. I just want to make an emphasis that it is in fact positive. Now, any questions? No judgment. Please stop me. I would be more than happy to try and explain. Okay, so everyone's on point? Okay. Is there something I wanted to say? I guess not. Here we go. Multiplying. It's very simple. You just have to know your multiplication tables, but that negative, you can assume that there's a -1 in front of all of these numbers, right? Multiplying by a negative number changes the direction on the number line. That might be a little bit hard for you to visualize, I chose not to, and I simply memorized, in this case, negative, negative became positive, negative, positive, blah, 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 blah. Again, it's up to you. 4 times 5, 20. Listen to what I'm doing. 2 times 9, just 2 times 9. Thank you, Zoe. But there's a -1 multiplied with a +1. Negative. That's how I did it. You don't have to do it that way. Yes, Ethan.
What's the opposite way around? -2 times the positive would still be a.
Yep. 2 times 9 and negative times a positive, -1. Give it up. So this would be a positive 42, and that would be 24, 40, -48. Calculator comes in handy. Yeah, so
Wait, is it that even number of negatives makes a positive and odd number makes a negative?
so it's a thing, right? It's like it's a good point. We have negative times a negative equals a positive. Negative times a negative times a negative is like saying a positive times a negative. I'll draw it nicer. A negative multiplied by a negative is a positive. But a negative times a negative times a negative is the same as saying a positive times a negative, because I already proved that 2 negatives make it positive. So you can simplify that way. What's interesting, this idea is pretty common in middle school math contests. Just this number idea, this number sense. You might have seen it if you've done division. Same thing. You just have to know your divisions, which is the reverse of multiplication. What do I have to multiply with the 3 to get a 27, or 27 divided by 3? That is, I'm going to rewrite this because I like everyone to get comfortable with fractions. That's a positive 9. 36. I'm not even going to look at the negative. 36 divided by a 12. Use a calculator. That's a 3. So we have -3. 77 divided by 11. 7, and negative divided by a negative again. It's like -1 divided by itself, positive. Half of 34. This is important. The wording is important. In mathematics, you will find anytime you say the word of in English, it equals. Oh. Sure, it's that same idea where I have -77 and I'm dividing by -11. First off, are you okay with the fact that it is a positive? Okay, well, 77 divided by 11, you could do it in the calculator, but the idea is if I have 77 pennies and I put 11 pennies into this person's pocket, I put 11 pennies into that person's pocket, 11 pennies into that person. How many people's pockets did I fill? It's the same idea as all the other ones.
Where you have to find out how many times one fits.
Correct. So this, yeah, so it's like it's 11 times what gives me 77. That's the question that we're asking. Yes, Maya? Sure. Her name? Yes, Sydney? Sure, absolutely. So this English stuff, I'll do it here like that. It's really messy. I'll try to do it neater after if you want. Half of 34. Remember, we said math was a language. There should be a link between English and numbers. Half. How do we represent that mathematically? There's 2 different ways you can say it. One, yeah, 1 is divided by 2. That represents a half of something, half of a pizza, half of a cereal bowl, half of whatever. Okay, what's another way we can show half? How about in, not in fraction, but some other way? Okay? Yeah. Either one. Of. That is a word that will almost always, like 99% of the time, will always translate into a multiplication. When you see the word of, it's literally multiplication. And 34. So right now, we're not going to work on fractions just yet. We'll save that until later. Half is multiplied with 34. So it's like saying 34 divided by a 2, right? Half of 34 is like saying 34 divided by a 2. That is 17. 0.5 multiplied by 34, again, 17. It's all the same. Yes, Ed? Yeah, go for it. Yes, Ethan? Mm-hmm. Nope. You can rewrite this as 34 cut into half of 34.
So half of 34 connects to 34.
Correct, right here.
Oh.
Yeah. Again, it's a communication thing. Absolutely. You can do either or. It makes sense, right? Neither person is wrong in this case. It's a language. You just got to get used to that. Correct. Now I could be long-winded and say one thing with 500 lines, or you could be super concise. It's like English. You have to fill like 1,000 word essay or whatever, right? And you start like adding filler words as much as you can. You guys know what I'm talking about? Yeah. Same idea. All right. Set the page. How much time do I have? I have to let you go in 15 minutes. Oh my God. Okay. It's because I'm so exciting. Yeah, you can't understand. Yeah. Oh God. I need to stop. Okay. I need to do two more things. We did bedmass, multiplication, division, addition, subtraction. We need to figure out exponents and brackets. Exponents. By definition, you know how multiplication was a short way of writing multiple additions? Like 2 plus 2 plus 2 plus 2 plus 2. I don't got time for that. Exponent is the same thing, but for multiplication. 5 times 5 times 5 times 5 times. No one's got time for this, so we shorten it to a new system. Mathematicians are, and so we developed a code. That's all it is. So if you see a little number on the top right corner of another number, it means that base was multiplied that many times, which is annoying, but it opens up a completely new world called exponents. And if you actually play around with it, you discover some interesting things, and you will see that this is going to be your favorite unit if you are interested in money and investment and percentage and gains and getting rich. You'd be surprised. Okay, so there's a reason why we do every single thing. Right now, it's basic, so it's boring, but it branches out into the rest of the world. So I hope that you will come along with me. Yes, Ethan.
Multiplication division, if there were two negatives that cross each other out,
Yes.
right? Does that count as one? So if you were
Well, we can actually write it out and you'll see that it doesn't. If you open it up and then it's like, oh, it doesn't, okay, I got to remember this. And then we develop some new exponent laws, which we'll see in the weeks to come. So yes, good. Let's try it for each example. So I don't think I have to go through it, right? Look at the base, look at the exponent. This entire thing is called a power. So terminology is important. Big number is the base, little number is the exponent. All of that is called the power. And first write the power in expanded form, which is multiply it all out, super annoying, and then evaluate. So you might want your calculator. Nolan, is that important? Okay. We've got, notice how I'm also writing the equal sign on the bottom, right underneath. It's a good habit to have, especially certain math teachers in Northern are big sticklers of format. So do your best to always have an equal sign underneath. This is 3 times 3 times 3 times 3. 3, 9 times 81. And it might be a good time for you to practice using that exponent number in your exponent key in your calculator if you have one. Take a look. For me, it's a little hat. Do you see that hat? That little arrow up. Let's see if I can turn off that light glare. There, that little hat. Okay. That's going to be 3 hat 4. 3 hat 4, 81. 3 times 3 times 3 times 3. For your calculator, it might be different. That's why it's important for you to practice with yours. Next, what if there's a negative inside the base? That's -2 times -2 times. Let's do the negative and the base separately. 2 times 2 times 2. Quick math. A -1 times a -1 times a -1. A -1 times a -1 times a -1. Negative, negative, negative. Check the thing that you just wrote. Check the note thing. No, this thing that we did. Check that. Negative times a negative times a negative. It's okay. No, we are on the back of the first page. And I moved a little bit quickly, asking if we were doing part B, a negative times a negative times a negative, it would be a negative. Yes. Correct. Good connection. Yes, Ellie. Correct. Correct. So it flips. If it was -2 times -2, it's a positive. 3 of these, negative. If I had 4 of these, positive again. So yeah, there's a weird relationship happening depending on that negative. If I had -2 times a -2 times a -2 times a -2, how many negatives am I multiplying? 4. All right, so I'm going to do this. I'm going to do minus, plus, minus, plus, and I'm going to flip between the two. -2 is, negative times negative is, at positive times another negative is, at negative times another negative is, times another negative is, it's going to keep on flipping. Okay, careful, careful. That actually, the next question is a trick. Is the negative, yes or no, is the negative a part of the base? What did I say about the negative being in front of the number again? Pretend that negative is a negative, -1. If there is no bracket, by the Bedmass rule, the exponent of 4 applies before the negative. I'm going to rewrite this. A negative power, so a negative 2 to the power 4, is the same as saying -1 multiplied by 2 to the power 4. So between a multiplication and an exponent, which one comes first? It's the exponent. So this one's going to be tricky. If you want to put a little note, do that here. Okay? Put a little note. If the negative is not within brackets, what's a way that we can understand each other? Should we just say exponent comes first? Would you understand what I mean if I say exponent comes first? Stefan, what do you think? Does that make sense to you if I say exponent comes first? Or should we explain it better? Like, should we elaborate? Elaborate? You don't like it? Okay. If the negative is not inside the bracket, then should we say the negative is not multiplied again and again? Does that make sense?
Is that right?
No, that's what's happening, right? See, notice how the negative is outside of that exponent power. If the negative is inside a bracket with the 2, then it's going to be multiplied again and again and again. But if the negative is not specifically contained inside a bracket, then this is actually that.
Why do we, is it just different ways of formatting it?
It's because of that math, yeah. Instead of writing it this way, mathematicians like, I understand it, and they stopped writing these brackets because they understood it. By Israeli, yeah, exactly. So again, it's a language, it's a code, unfortunately. So how about I write this? If the negative is not within brackets, it is not multiplied again and again.
Before we leave, can you go over like on the other side?
Yeah, I'm gonna see if I can get to that. I'm gonna probably leave these. I'm gonna do one more. And so this is, let's finish this. 2 times 2 times 2 times 2, 16. And then the negative 1 multiplies to that 16. So the exponent comes first. Okay. Pardon me?
There's nothing there. But if the
Correct.
exponent wasn't on, it would jump.
Correct. So for this one, the answer it will always be a negative because that negative is applied after. But here, the negative keeps on flip-flopping. And you will see your calculator also follows this. The calculator is too smart for its own good. If you don't add a negative within a bracket, it'll assume that you're doing this. Yeah, it assumes you're doing this one. You must put it in if you want the calculator to understand as well. So let's hammer out. I got 5 minutes with you. Let's hammer out what each of these letters mean, and we have to follow this in that order. And then we will try the very last one together, and you have homework. Here we go. Yeah. We started at 12:20. No, 1:35. 1:35. I got time with you. I've got time with you. Oh my goodness. I'm so used to being in such a rush. And that's all recorded on YouTube too. I'm so embarrassed. Yeah. Because there are some people who are, yeah, well, maybe. Yes, Leon. Because I'm amazing and I do amazing things. I wouldn't be offended. It's just embarrassing for me. That's all. All right, here we go. Bed mass. Bracket. Bracket. Okay, so please note, division and multiplication are interchangeable. They are at the same, I guess, location, the same level of strength. I don't know what you want to call it. Same with addition, subtraction. You can do it in any order you want. They are sort of together, but brackets must be done first. Anything inside the bracket, it must be done first, and then comes exponent. Yes, Nolan? Yes, absolutely. Name on the board, please. Okay. So I am going to, as a class, try that last big one with you. And then I have a bit of a food for thought. It's an interesting sort of puzzle question that you might have seen on the internet if you nerd out like I do. All right, so here we go. I'm pretty sure you can fill this in. Following bed mass, here it is. I am going to first do this because that is inside the bracket. Let's work that out. 20 minus 2, 3 squared plus 22 to the power of 3 divided by 4. I don't care if this is a subtraction. It's inside a bracket, so it must be done first. And you will only not make that mistake with practice. It becomes second nature. You don't even have to think about it, but it comes with practice. You must. Next, let's use a different color. I see an exponent here and I see an exponent here. By bed mass, that has to come first. So 20 minus 2, 3 squared, 9, 2 cubed, 8, 4. All right, B is done, E is done, division, multiplication. So here's a multiplication. Here's a division. I'm not going to touch anything else. Yeah. And then the rest you can do as you see fit. The final answer is a 4. And let me tell you the main reason why I'm pushing this, even though it might be basic to some of you. It is because sometimes I will ask you to do things without numbers. I'll ask you to do things with mystery numbers, like an X or a Y or a Z or an A or a B or whatever. But you still have to follow bed mass. So get really good and comfortable with it while the numbers are still there, and I'm going to take that out one day. So, yes. How many names are? Yeah, go for it. Any questions? All right. So please note, as I said, homework checks are going to be every day. Your homework, as long as it is, since we do have a good, like 15 minutes, you can get started. It is this section right here, just on the bottom of the page. On the back, there is a number 3. Just think about it as a thinking question. There are answers available already. But here's something that you might see on the internet that I found interesting. All right, let's see what you have to say. What is the answer to, let's see. Wait. Is this it? Okay. Okay, everyone, take a look. Here's a question where, according to bed mass, you could do division and multiplication at the same time or in any order you want. But try it. Okay, there's no addition, no exponent, no nothing. It's not a trick question. If you decide to go this first, what's the answer? 20 divided by 2 is a 10. 10 times 5 is 50. But what if I do this first? That's a 10. So what 20 divided by 10
Or it's a 20.
Which one's the right answer? Hmm. Okay. Okay. That's not a bad logical suggestion. Okay, but not division or multiplication in any order you want. You could do division first before multiplication. That's still okay technically. But there is a specific, one of these is right and one of these is wrong, just because of mathematical convention.
You're supposed to go left to right.
So same suggestion. That's a very logical suggestion. Absolutely. Anyone else? If you went from left to right, what is the answer? 50. Anyone else? Have another argument for it? Well, this is what I mean by the language, right? Even English, people will argue over English. That's why there's a huge target of it. Not just specialty professors or hammering into the English language, while the Oxford Dictionary constantly evolves. The correct answer is 50. And you are correct. When you are given a mathematical statement, just like a English sentence, if there is an ambiguous situation, you go from left to right. So you do this first, and then you multiply them. Okay. Oh. Anyways.
You keep doing that.
Oh, so my life is so hard. Okay, I'm gonna stop here. Everyone, would you please consider doing some of the questions before you go, but I do sign you off in about 10 minutes, so you are free to relax as well. I'm gonna stop the recording. Questions?